In this video, I'll be making a simple stair asset. This asset will be used to start blocking out levels. I will start by adding a geometry node, which I will then convert into a digital asset. I will hide the existing parameters, and then I'll create 4 parameters. These will be for the height, the length, the depth, and the number of stairs. To make the basic stair shape, we're going to be using an L system. First we'll go to the Rules tab, and then we will set the premise to A. We will only need one rule, and that rule will rewrite A. The rule we use will be A equals F plus F minus A. My apologies for my terrible typing. After we press enter, we will see that the result does not look like stairs. To fix this, we go to the Values tab and set the angle to 90 degrees. We now have the basic step shape. To control this shape, we're going to be using the variables in the Values tab. We will use variable B to control the height, and we will use variable C to control the length. After returning to the Rules tab, we're going to modify the Rule 1. We will add variable B between the F and the plus sign. This will be done using parentheses. And we'll add variable C between the F and the minus sign. The variables now control the length and the height of the steps. The next problem is that I want the length and the height to be constant, and instead drive the steps by the number of divisions. I will open the SAS parameter window to make it easier to drag and drop the parameters. To get the correct length and height, we are going to divide them by the number of steps. The default value for the number of steps is currently 0. We will need to change this to prevent dividing by 0. And I'm also going to clamp the length and the height into a positive value range and set their default values to equal 1. Variable B will now be driven by the height parameter divided by the parameter for number of steps. I had not yet renamed the parameters, so I quickly renamed them in order to make things more readable. Variable C is then updated, and under the Geometry tab, I changed the generations to be driven by the number of steps. We can now control the height and the length. We can also determine the number of steps, but the number of steps does not work as desired, as it's giving too many in-between values. In order to fix this, I will change the parameter to an integer in the Type Properties window. Because this is going to function as a profile, we will need to add a back and a base. To do this, we will need to get the final point, and to get the final point, we will use a group by range node. We want to set the group type to points, and then set the end to 1. This will remove the last points from selection, and when I invert the range, I am left with a group containing only the last point. Finally, I'll use a blast node to delete all points except the final point. Next, we will use the add node. The add node will add 2 points. The first point will be directly below the final point in the stairs, and the second point will be at 0 in the X, Y, and Z axes. To get the X position of the final point, we will use the bounding box function, and we will use the maximum X position of the blast node. Finally, we select the polygon tab and select the by group option. And now we should have our base and our back for the stairs. And all that is needed is to use a merge node to merge it with the L system. I make an error here by using the fuse node instead of the join node. This is corrected in the current version of the tool. In order to get the extrusion to work properly, we change the extrusion node to point normal. We will now add a transform node. I want the stairs to be centered along the x-axis, so I'm going to use the transform to compensate for the extrusion. I will drive the transform's Z position with the depth parameter. This value will then be divided by 2 to center the position on the x-axis. The depth parameter will also drive the extrusion distance. This value must be negative. A Polycap node is used to fill in the ends, and I set it to triangles to get a more accurate final geometry for the game engine. And now I've got a working simple stair asset. We now return to the type properties. I've got a switch node which I'll use to select different functionalities for the steps. I drag the switch import to create a parameter. I then change it from an integer into an ordered menu. I then managed to put the values in the wrong way around. It's not very important at the moment, but I should have been paying more attention to what I was doing. I will now duplicate the extrusion and plug it into the switch node. Next, we'll add a resample node. In order to make the resample more accurate, I check resample by polygon edge. And then I change it to maximum segments instead of segment length. I now fix the menu by putting the numerals under tokens and the names under labels, and not the wrong way around, giving myself a menu for simple and bendable stairs. The resample node has stopped the Polycap from working. To fix this, I use a fuse node. And just to be sure, I add one to the simple stair path as well. I will now get a bend node in order to bend the staircase. The main reason for centering the stairs along the x-axis was to allow for a more accurate bend. The bend node is currently facing the wrong way. I update the capture direction to face along the x-axis. The capture length can be used to alter the deformation, but I want a consistent deformation, so I will drive the capture length with the staircase's length to make sure that the capture is even along the entire length of the stairs. We can now bend the stairs, but they're bending along the wrong axis. To fix this, we need to change the up vector to be 1 along the z-axis. I was not happy with the sampling here, as there's too much extra geometry and the deformation is still not what I wanted. In my first attempt to fix this, I separated the resampling of the stairs and the base so that I could resample both curves separately. After I'd done a lot of other work on the stair system, I came back and fixed the resampling issue. In the end, only the base needs to be resampled, and the number of segments can be driven by the number of stairs, so no extra parameters are needed. To do this, I used blast nodes to separate the lines for the side and the base. I resampled the base with the number of segments being driven by the number of stairs. For the next part of the stairs, I add a curve and an object merge. I then draw a curve using the curve node to create a default curve. Finally, I add a switch node and connect both of them to the node and rename them to user curve and default curve. I then use an if conditional to check if the number of points on the object merge is greater than 0. If they are, we will use the object merge. If they are not, we will then use the default curve. We will then open the type properties, and selecting the object merge node, we will drag and drop so that we can create a parameter to allow the input of a user curve. For the sake of neatness, I use a null to output the stair profile. I then use an object merge to reference this null. The next step is to get a sweep node, which we then connect with the object merge in the first input and the curve in the second. We want to set the parameters of the sweep node to use one primitive at a time and to skin unclosed. I also tend to prefer angle fix to be on by default. We now go to the type properties and add a menu entry so that we can now select the curve as an option as well as the bended stairs and the basic stairs. It is now time to add a basic UV set to the stairs. The stairs are currently test geometry, so the UVs do not have to be perfect. To generate the UVs, I'm going to use a UV auto seam to generate seams and a UV flatten node to separate the UV islands. This is rather crude, but the results are more than good enough for what I currently need. The UVs for the curve are far more complicated than those of the steps. First I'll need to check the point numbers, as I want point 0 to be at the base of the stairs. Then I add a convert node, and I convert the curve to a NURBS curve. I then check interpolate between hulls and change the U order to 2. We will then add the UV texture node, and we'll change the type to arc length spline, which will give us the basic layout for the curve. In order to get an accurate length, we will use the arc length function, and we will use it in the X scale value. We We will reference the object merge node. It will start at the beginning, go to the end, and the curve will start at the point 0. I now have my stair unwrapped. I'm going to change the attribute class to points. Then I will rotate the UVs, and I'll rotate them to -90 degrees. We will then add another convert node and convert back to polygons. I'm then going to duplicate the nodes and put them in between the switch nodes and the sweep. And I'll change the object merge in the arc length function to be the switch node. There are now a couple of bugs which I need to sort out. The first was that I forgot to correct the angle on the UV texture node that I had copied for the switch node. Then there were a couple of bugs which came from the fact that I forgot to change all the values on the sweep node after I'd had a crash, and therefore the sweep node was not acting correctly. The next error was on the convert nodes, when I converted the NURBS curves back to polygons, and I forgot to check interpolate through holes. The final error was caused by the fuse node. I replaced that with the join node, and then in order to make sure the ends for the NURBS curve were no longer fused together, I used the ends node. And with the ends node, I set clamp U to unroll. So here is the node as it currently stands in Unity.